So today I'm going to give you just a little bit of a introduction to Shardis. It won't be that super technical. It'll be a little bit high level, but maybe another time, I could do another presentation to make it more technical. But this time there's, so much aspects to it and so much background to it that, in order to cover it like within about 45 minutes, I wanted to kind of keep it a little bit high scale or high level and not go into too much of the details of uh, the technical aspect of it. Um, okay, so uh, before I jump into like, Shardis and the features of Shardis and so forth, I want to kind of give you a little bit of background as to why we're even trying to build Shardis and our motivation for doing this project, which is kind of pretty interesting. Um, so back in 2008, I was introduced to the problem of sound money by listening to lectures from Ron Paul. He was running for president at the time, and he would often talk about how we need to go back to sound money and get off of the current fiat system. And at the time, I didn't know what sound money even meant. But basically, what it means is to back your currency with some kind of a commodity like gold. Usually, it's gold. Um, and so, when I started investigating that and learning a lot more about money and how money works and so forth, I kind of came to the conclusion that, why does it have to be some commodity that has to back the gold? Maybe it's possible to have, these kind of features in a purely electronic money that is not necessarily backed by some commodity, uh, but you still have the features of, not being able to print as much of it at any time and so forth, and really have it be, stable and feel like a hard money. So in 2011, I wrote this paper called Sound Money Without Commodities. If you just Google for that, you could find the PDF for it and check it out. But in that paper, I proposed a rule-based monetary system, which is very different than our current monetary system, right? So our current monetary system is kind of like top down, where the new money gets created at the top, and then it trickles down, to the government, through companies, and then finally to individuals. Um, but I kind of inverted the whole system where the new money is created at each individual, and then it can trickle its way up into the economy. And so basically, if you imagine like each individual has a balance represented by B, and on a periodic basis, it could be like each day or each week, um, you add to the balance some, uh, daily or periodic universal basic income, which is represented by U, a constant amount. But then you also subtract from it a small percentage of that balance, right? And that's referred to as demortgage. And that's, D is like a constant that you can use to control how much, you take out of that balance. And so eventually, initially, if you did nothing with your balance, you could see that the balance would accumulate as you would continue adding every period. But eventually, the the U would equal, the amount that's being taken out by the D times B factor or term. And so you can see that there's going to be some kind of an equilibrium at, U divided by D. And so the supply in that, or the supply of money in that account will not exceed this equilibrium level unless you were adding even more to it than what U is providing. And so you could, from this figure that each individual on average would have an amount equal to E, but the total supply in the system would be the number of participants in your economy times that equilibrium amount. So, if N is the number of participants in your economy that are receiving this, universal basic income, then the supply of money would be proportional to the number of participants times what the equilibrium factor is based on, what you chose for U and D. So, this has like some really nice properties. It tends to be stable without requiring things like other, collateral to back that money, or using multiple different, kinds of bonds and senior shares and things like that. So it has really interesting properties. Now, after I, thought about, creating a system like this, I started thinking about, well, how could this actually be implemented? And, at that time, I had no idea about blockchain. And so I was thinking more in terms of something like a domain name registrar system, where you could have an organization like a money registrar, where you would go and create an account with this money registrar, and you could only create one account because, that one account would start receiving that, universal basic income. And, that kind of a system could potentially work. But I started to notice that, hey, eventually you're going to have a trust problem with these money registrars, because if this was really a global scale system, some of the money registrars in some of these countries might not be so honest, right? I mean, they might create fake accounts just to collect money and so forth. And so I was, not happy with that solution. And I was searching on the internet for, what are there other digital currencies and things like that? Because I knew, like, back in 1990, there was a project called DigiCash, and I wanted to see what was happening with that. And so when I was searching for DigiCash, I ran into Bitcoin and blockchain, and I guess that had a really big impact on on my life and future. And so when I saw Bitcoin and blockchain, I was just like, wow, this is totally amazing. Here, there's all these different nodes that don't trust each other and are able to come to consensus and work together. And I knew right from at that point that I want, that a rule-based system could potentially be implemented through this kind of a network. And so, blockchain solves that, third-party trust problem. So I don't really need any kind of a money registrar. And you could just have a network of nodes that implement that, the rules of this monetary system. And when we look at this period of time, we're going to really see that because of blockchain, we now have this ability to implement monetary systems that are rule-based, which before we could not do that. And the only way we could create monetary systems was to have centralized organizations, have a privileged position where they, kind of are in charge of that. And so we're moving into a very different period of human history with this technology, which is making this possible. And so I then wrote another paper called, about global electronic trading coin, shortened to Getcoin, which is basically a cryptocurrency that's a stable coin based on universal basic income and demurrage. And I refined that ideas from the first paper so that it's implemented using a blockchain-like system. Now, at that point, then I realized that there's blockchain solves some of the problems, but it also introduces some new problems. One of which is, the proof of individuality problem. If people that have created an account on this system are going to be receiving a universal basic income, then there's going to be a lot of incentive and motivation for people to create multiple accounts. So how can, the system ensure that, each individual creates only one account, and that every account has a real, human behind it? So that's a problem in itself. And, I'm not going to talk about that, but we did also address that problem in another paper. But today I'm going to talk about the problem of scalability that, blockchains kind of had. So at the time, a typical blockchain, you could only get, about 2 to 20 TPS. Partly it was because of the blockchains, limiting their own scalability by introducing, things like the block size and, how often a block is created and things like that. But even if you try to push these to their maximum limits, you're probably only going to hit like, maybe 20, maybe 50 kind of TPS. So, the problems, that blockchain creates, actually, I kind of covered this. And so, I wanted to address that whole scalability problem because the current solutions only had about, 20 TPS, and to really do like a global currency that's universal basic income and, people could receive it, you would really need millions of transactions per second to be able to handle something like that. And so that was a really big problem, and wanted to really think about this. And I, kind of hoped that somebody else would do it and come up with a solution. And I kind of waited until about 2016. And you probably remember there used to be conferences about, blockchain, scaling Bitcoin and things like that, talking about how we can scale blockchain. But a lot of these solutions were focused on, layer 2 scaling. And, for the kind of application that we wanted to do, I really wanted to have something at layer 1 that could really scale. And so having a background in building scalable systems at, lots of different organizations, I decided to leave my consulting job in 2016 and just, focus on this problem. And so I kind of locked myself up in the library for about a year and a half, putting down on paper a lot of the design ideas that I had developed over the years for scaling, blockchains, and pretty much started with a blank slate, like not taking anything that's out there, but looking at it and saying, well, if I could just start over and build something from scratch, how would I do this? So that's, our motivation really, and that's how Shardis got started. So now to get into like, what Shardis is, so what, it's basically a framework for building decentralized networks. So it's not a smart contract platform, because a lot of people, when I tell them about Shardis, they immediately, think that it's, some kind of a network that we're going to launch. Shardis is not the name of a network that we're launching. It's the name of some software. So we're not like Ethereum or, Elrond and a lot of these other smart contract platforms. You could think of it more similar to something like Hyperledger, where Hyperledger is a framework for creating your own decentralized networks. But we're not so focused on the permissioned aspect of it. You could use Shardis for a permissioned network, but really we've designed it for a permissionless environment. And you know, we really think that this would be some software that could be used for applications like, you know, building decentralized social networks and things like that. So some of the features that we wanted to tackle in Shardis and improve upon the status, you know, of what we already had, primarily was scalability, right? So the first generation networks, you know, like the Bitcoin and Ethereum, had low TPS, partly because, you know, they wanted to limit the block sizes and the rate at which blocks are produced and so forth. But even if you try to push that to the max, you would still start hitting, you know, bottlenecks, you know, due to bandwidth and CPU and things like that. Now, the second generation networks that you see now that are coming out these days, you know, a lot of projects out there now, you know, like Algorand and Alrond and Avalanche and Harmony, and there's just a whole bunch of them, even the Binance Smart Chain. So these platforms have kind of, you know, compromised on decentralization in order to gain that speed. And a lot of times they've really just focused on increasing the speed as opposed to scalability, right? So they're going to also eventually hit some upper limit, right? It might be, you know, 1,000 TPS, or it might be 10,000 TPS something, but eventually those networks will also hit some upper limit. Now, the ultimate goal is to have linear scaling so that you don't hit any kind of upper limit, and you can continue to, you know, have more and more speed and throughput just by adding more resources to your network. And ideally, you would like it so that every node that, you know, joins the network increases your TPS and increases your storage capacity of the network. And so that was, you know, our primary goal. And we've achieved this using state shard, excuse me. So we've achieved this using state sharding. And the way we're doing sharding is quite different than a lot of the other projects that are out there. Sometimes projects will refer to sharding when actually, you know, they're having multiple different networks interconnected through a hub network, or they'll refer to it, you know, or they'll have sharding where the shards are very fixed and have, you know, fixed boundaries. And, you know, you can't create another shard until you've had, you know, some X number of nodes join the network and so forth. But the way we're doing sharding is quite different. We actually call it like linear, or not linear, but dynamic sharding. The other aspect of, you know, some of the features that we wanted to maintain with Shardis is the decentralization. Now, you know, decentralization is one of those things that's, I think, very, very, very hard to maintain long term, right? And it's one of those slippery things where you think you're decentralized, but certain parts of your solution can become centralized, even though you may have started in a decentralized way. So like the first generation networks, I think, have lost some of the decentralization. You know, back when I found Bitcoin in 2011, it was extremely decentralized. You know, we were able to run nodes from our home computers, and you know, you had thousands and thousands of different people joining the network and contributing to it. But that level of decentralization has been lost now. With, you know, we just have a handful of large, you know, miners contributing to creating those blocks. And a lot of the other people that are trying to participate in mining are really just providing compute resources to, you know, the miners that are actually running the pools. Now in the second generation networks, they kind of already compromised on decentralization, where they have what are referred to as delegated proof of stake type networks, where, the nodes that can participate in the network are, semi already picked either by, staking or by, the users in the community voting on those, on which nodes can produce the blocks and so forth. Our goal with Shardis was to allow a large number of independent anonymous nodes to be able to join the network and participate. And one of the things that you need in order to achieve that, I think, is to ensure that your network can run with low resources and just using, off-the-shelf hardware and not requiring any kind of, special hardware, like ASICs or GPUs and things like that. So that was, one of the our key driving factors in designing Shardis. And then, of course, security is critically important. So with proof of work type networks, you know, they end up having to spend a lot of energy in order to maintain that level of security. I think long term, this is not really sustainable. You know, Bitcoin kind of is doing it, and it was the first one, and it's still being able to continue doing this, but it'll be interesting to see how long and how much of the world's energy starts going into the Bitcoin network. Now, we wanted to get away from, using proof of work just because it was so, consumed so much energy. Now, proof of stake is a good alternative. However, one of the drawbacks of that is that the security of proof of stake is kind of dependent on the market cap of that network, right? In terms of what is the token value. And if your token price becomes really, really low and the market cap of your network becomes really low, then it's easy for somebody to, buy up that token and stake and take over the network and have it go their way. So proof of stake kind of helps reduce the need for spending a lot of energy, but I think that having it tied to the token value is kind of an issue. So with Shardis, we decided to use a classical, consensus algorithm, practical Byzantine fault tolerant, and we modified it somewhat. Now with the typical PBFT, it's limited to using small networks, and you have to have, some kind of a public key infrastructure, which is kind of associated with, more permissioned networks as opposed to permissionless networks. So what we did was we used just PBFT just within the shards as opposed to like a complete, 1,000 or 10,000 node network. We do it just within shards where, the shard size may be limited to like maybe 100 nodes or so. And then also we allow the nodes to self-assign their keys so that it can remain permissionless. But with this kind of a modification, you now start to have issues with, how do you prevent a 51%, shard attack, right? Like one shard being taken over. And so some of the things that we've done to prevent that is, even though the nodes can, pick their keys, the key doesn't determine which shard you get assigned to. Instead, the network uses a combination of your key plus some random data from the network to determine which shard a node would be assigned to. So it becomes more difficult for an adversary to try to, get all of their nodes in the same shard. In addition, we periodically rotate the nodes in the network and even what shards they're contributing to. And so that also helps to prevent like a 51% shard attack. Another feature that we have in Shardis is, like the ability for the network to look at itself and detect how much load is being thrown at the network, right? Um, so, the nodes can come to consensus on, how big the network should be. So, when you have a network that can actually scale and have, higher throughput based on its size, then it kind of starts to make sense to have the network look at itself and make a decision about, hey, do I really need to be, 10,000 nodes? Or, is the load that I'm seeing right now sufficiently handled by like maybe 100 nodes or 500 nodes? And so, in Shardis, we allow the network to auto scale so that it can grow if it receives more traffic, and it can, reduce the size if it sees less traffic. And I think that's important in order to increase the efficiency of the network, and eventually that leads to having, a minimum expenditure on maintaining the network. In addition, in Shardis, the nodes are able to do what's called rate limiting, where, they can drop transactions if they're hit with a lot of DDoS or spam attack. And so, this reduces the possibility of a network getting bogged down just by somebody, hitting it with a lot of spam or DDoS. And so when we are dropping these requests, we had to choose consistency over availability. So like every transaction that's given to the network doesn't automatically get added to a queue and eventually gets processed. Instead, the network tries to provide, fast finality on every transaction that it sees, and, provide some kind of a guarantee as to, how long it would take that transaction to be processed. And so, in terms of like the CAP theorem, we've chosen to go with consistency over availability. And another aspect of blockchains is their interoperability. So right now, a lot of the early blockchains were really not designed with interoperability in mind. Each blockchain is kind of a silo in and of itself. We're starting to now see other networks which are able to help you, move value between these siloed blockchains using some of the newer cryptographic primitives, like threshold signature schemes that have, made this possible. But which, Shardis, what we wanted to do was allow the networks to directly provide APIs very similar to how our web services are currently interoperable, right? So a web service will just provide some APIs, and other websites can, use those APIs as needed and pull in that data and, transform that data and use it to display other, processed information from their site. And so we believe that, allowing these blockchain type networks to directly expose APIs that thin clients can interface with, and other blockchains can interface with, is a key factor to enabling interoperability. And when you have, customized blockchains, you can also have the blockchains, build in their own oracles and actuators so that, they can go out and collect data from other blockchains and send messages to, activate some action to happen in another blockchain. And so overall, what we're trying to do is make it more feasible for someone to create a custom decentralized network, right? Currently, uh, if you wanted to go and create your own decentralized network, it's really a hard problem. And so, nobody wants to do that. Everybody just wants to write smart contracts and have it run on a blockchain that they know is, you know, already able to handle that. So that way they don't have to deal with the security issues. That way they don't have to deal with the high cost of development of creating your own blockchain and so forth. But if we can bring the cost of creating and launching your own uh, custom blockchain to be much lower, then I think we'll see just a whole universe of custom blockchains popping up in the same way that, we saw lots of web services, pop up in like the mid 1990s. So who would want to use the Shardis software that we're developing? So our team um, is definitely planning to use the software that we're building. Um, so we have plans to create our own custom network called Liberdis, and it's going to provide features on there such as private, encrypted end-to-end messaging, the ability to do crowdfunding, which I think is also something that's very lacking currently in our ecosystem, is the ability to do like decentralized crowdfunding, um, and also we want to use Shardis to eventually create the Getcoin system that that I talked about earlier, and that was our original vision. Um, and in addition, we want to use Shardis to create a decentralized identity and reputation network, which we call Globalville. So there's those and other projects that we want to do in the future using Shardis. But we also see that, once the software is available and we've demonstrated some projects by creating them on our own, I think there's a lot of potential for other, projects to use Shardis, especially, in cases where you don't want to have your uh, blockchain be impacted by the traffic on other applications, right? Like if you put it on a smart contract network, like Ethereum or one of these other ones, then your traffic is kind of shared with the traffic of other applications on that. So in a way, it's kind of like shared web hosting as opposed to dedicated web hosting, right? And so anything that requires high throughput and a high degree of decentralization, I think they would definitely want to use something like Shardis. And so, things like social networks, games, and large scale global services could potentially use Shardis. Enterprises could also use it where, if they had situations where they have high throughput and they have federated data that, storage and services that are shared between multiple different companies, um, they could use, Shardis in that case. And of course, it could be used for, ensuring business continuity planning and creating immutability and redundancy of the you know data storage. Now, a little bit about the Shardis project itself. Um, so we're organized as an association. We're basically a group of developers coming together to work towards a common goal. We wanted to kind of keep this structure because this is the way a lot of the really great open source software has been developed over the years, right? If you think about like Linux, there isn't a company behind Linux. It's just a group of individuals coming together to create and contribute towards a piece of software. A lot of the a web browser software is developed that way, and even Bitcoin and was originally developed that way. Even there's now a Bitcoin foundation, but the foundation is not really in charge of the Bitcoin software. And so what we do is each quarter we do a presentation of what we're doing. And we've been working on this since like 2018, and every quarter we've done a presentation to kind of give an update of how the project is coming along. And we have about 10 core people that are contributing to the project. There's also a token that we have with Shardis, and the contributors earn the Shardis tokens. We've never done any kind of an ICO or private sale of the token. In fact, the Shardis project never ever sells or buys the tokens. It only gives the tokens to people who directly contributed to the project. But those that have earned the tokens, they can transfer the tokens, they can exchange it, and so forth. Since the token is an ERC20 type token on the Ethereum network. And the utility of the token is basically that it will be consumed when projects want to get a license to the Shardis software. So there's two ways. One is that Shardis tokens would be acquired and burned to obtain a license. The other way is that a project can give some of the tokens on their own network to people who are holding Shardis tokens and allow them to come to their network and claim tokens on their network by proving that they are holding Shardis tokens. And so, the token is out there, and, there's information about it on, some of these websites that list tokens like CoinGecko and CoinMarketCap. And so, we're always open to have, people who want to contribute to something like this, join the Shardis project and, contribute in any way that you can. Of course, we're always looking for, talented developers, but, if you can help in other ways, there's a lot of need for lots of different things on a project like this. And you can learn more about Shardis by, going to our website. You can find our white paper there. There's, links to our social media. We also have a newsletter that you can sign up for. And, if you want to check out the videos that we've, made from our quarterly events, you can just go to YouTube and search for Shardis, and there's a lot of detailed information about the project there as well. So with that, I'll wrap it up, and I can take questions.
All right, thank you, Omar. So I will start. So I have lots of questions, but the first question is, when you are talking about the 51% attack, so we know what does it mean, proof of work, proof of stake, but what does it mean for Shardis?
So with the network that's sharded, what you have is, sharding basically means taking the total nodes that you have and subdividing them into smaller groups called shards. Now, consensus could happen just within a shard, and consensus doesn't require the whole network to participate, right? So you might have a network of 1,000 or 10,000 nodes, but your shard size may be 50 or 100 nodes. And so if consensus is happening just within that shard, there would be incentive for someone to have all of their nodes go into one shard, so that they can maybe change the balance of an account that's handled by that shard, for example,
Mhm.
or process some transactions that are routed to that shard. And so you only need to do a 51% takeover of the one shard. And so you know, it reduces um, the difficulty, because in the past, if you had a 10,000 node network, well, I need to have 51% of that 10,000
Mhm.
nodes, and that's a very hard, a much harder problem than just getting in like maybe 20 or 50 nodes in one shard. And so that's always a concern for any kind of network that's sharded. And with Shardis, our approach to that has been to ensure that any node joining the network does not get to pick what shard it can go to.
Mhm.
And so there, a node is allowed to join the network in a permissionless manner, but it doesn't get to join, select which shard it gets assigned to. And that's done through, a method that incorporates some random data generated by the network along with the key that's presented by the node. And the combination of that determines what shard the node will participate
Yeah.
in.
But how do you
And
quantify the contribution of a node? So when we are talking about nodes, it's like they have the same contribution. So if they have 100 node, so if 51 nodes, I mean, is malicious, so they will attack the shard. But how do you quantify the contribution of a node? I mean, in proof of work, we talk about the hash power
mm,
or the stakes. But in your case, because you are using different consensus, so what is, how do you quantify the contribution of a node?
so basically, with like PBFT, what ends up happening is a group of nodes, uh, come together to create a receipt and sign
Okay.
off on that receipt. And so every transaction that comes into Shardis will be, viewed by the the shards that transaction impacts. And so those nodes in those shards need to approve that transaction and validate it
Hmm.
and sign off on,
Okay.
on the hash of that transaction to say that, hey, we've accepted this transaction. And so that ends up creating a receipt.
Okay.
And so that's the contribution that each node is making towards the consensus.
Okay. And for the load, how do you compute or measure the load? So when you decide that's okay, it's time to increase or it's time to decrease. How do you in 10,000 node, or I don't know, how do you?
Yeah, that's actually a very, very difficult problem. And that's something that, we've been able to solve. I'm not, I have to be careful and not to go into all of the details, but, because part of what we want to do with Shardis is we are going to file for patents,
Okay.
in a defensive way so that some of the technology that we release can't be used in a offensive way, right?
Hmm.
So that somebody can't, uh, you know, use that against us and say like, hey, we patented it first, and so you can't
Okay.
use it,
Okay.
right? So, but I will go into a little bit of detail. Um, so give me 1 second. So your question again was regarding
The load.
the right, the load balancing.
Hmm.
So part of it is that if you assume that different transactions come in and they're uniformly distributed, just routing the transactions to the different shards tends to balance the load across the network. But detecting how much load the network is seeing, what we do is we use a queue that keeps track of how many transactions the node is processing. And by looking at how large that queue is getting and how many transactions are pending in the queue, that kind of helps us kind of gauge, how much load the network is seeing. And so that's part of the solution, but then you have to have a network level consensus
Mm-hmm.
on all the nodes agreeing to say, hey, we're seeing so much load that we need to increase the network size.
Mm-hmm.
And you can kind of think of it as, even in Bitcoin, the nodes do that whenever they, increase the difficulty
Yeah.
level based on, how long has it been taking for us to generate the blocks, right? So, we have a deterministic way to use the information on, how much the nodes are backing up in their queues to decide how much load the network is seeing, and then to come to a consensus on increasing the network size.
Okay, thank you. I will stop. I have more, but I will let
Yeah, I
others
would
ask
definitely like to
questions.
maybe sometime come back and do a
So,
more technical presentation. I know this presentation was kind of low on the technical details, but there's so many different aspects of what I covered today that I could, go into a whole hour lecture. Like just even the whole the universal basic income based cryptocurrency. That could be a topic in itself. How we're doing different aspects of sharding could be a topic. How we do our load balancing and network level consensus, that could be a topic, and even what we're doing with Liberdis and so forth. All of these could be
Mhm.
multiple topics that I could talk about for hours. So, but
Okay.
anyways,
so, so let me ask a question. So I have many questions too. So, but I have some technical questions. But if not the time, if not the right time, so we can just you need to promise us that you will give us many presentation about tech, because I have many technical questions. So I will ask. By the way, I will ask some one or two, just one or two technical questions, and we can list the others to another time.
sure.
So the first question that I have, okay, so the first question that I have is, what about the resiliency of a shard in Shardis?
So,
What
what do you mean by the resiliency?
I mean, how much can support of the malicious nodes or malicious IDs? How much
Oh,
can
okay.
support?
Yeah. So, it follows pretty much the same security model of, PBFT, right? So, uh, you would need 51% of the nodes to
I,
sign off on
um,
approving a transaction. But, with that, if you had, 33% malicious nodes, you could cause a partition, right? Within that shard. Um, so,
yeah. Yes, it is about 33%, I
right.
think. Yeah, it is not 51, it is about 33%. So, and how you deal with the a shard can take over attack?
So the two you know aspects that we have in Shardis that help prevent that is that in order to get a 51% of the nodes in one shard ends up being the same as trying to get 51% of the nodes in the whole network, right? So the difficulty ends up being about the same. And that's because you don't get to choose which shard your node falls into. Um, and that's done by having, the network generates some random data that's used in generating, what uh, part of the network the nodes contributes to. The other aspect is that we rotate the nodes so that any one node doesn't stay in the network for forever. Ideally, what we would like to do is have, like, let's say you had a network of 1,000 nodes that are actively contributing to generating, or validating the transactions. You would actually like to have like maybe 5,000 nodes that are willing to participate and contribute. And so you could have, nodes that are waiting to join this network, which, come in, and other nodes are leaving the network. And so you continuously have a churn.
Yeah.
And, it makes it more difficult for an adversary to establish any kind of gain that they, get in
Yeah,
the
in a big
shard.
sample.
But I think there are some probabilities there, so there are some calculations
Right,
there.
right.
But even randomly, shard can be take over attack.
Yeah, I mean, if
So
you have like 51% of all the nodes that ever want to join the
it is
network,
in
then
shard
yes.
it is not, yeah, in the shard it is not 51%. It is just 33%.
Yeah, right, right, and that
Yeah,
could cause a
yeah,
partition, right? Just
yes,
having
can be,
33%.
yeah. Yes, if just overpower the 33%, you can attack the network. So I think there is some probabilities there. So I have another question, but I think you are already talk about periodic node rotation. That means the nodes leave and join periodic node. What do you mean by periodic node rotation?
Yeah, so the network itself, it's permissionless in the sense that nodes can attempt to join the network, and the network, depending on whether it wants to let more nodes in, would accept that join request. But periodically, the network itself, even like, let's say the network says, I only need 500 nodes, and the load that I'm seeing is doesn't require me to grow the network size. You still periodically get rid of some of the older nodes that have been already in your network for some time, so that new nodes can join. So so even though the network may not be growing in size, you periodically shed some of the older nodes to allow new nodes to join the network. So that way you have
Okay, thank you.
the
Thank you
rotation
so
of the
much.
nodes.
Very nice. Yeah, it's very interesting. Thank you.
Mm-hmm.
Any more questions? We still
Yes,
have
I have one thing to ask.
5 minutes. Yeah, go ahead. Yeah, sure.
It's very nice to see, Umar. I think we have been conversing on LinkedIn for a while, and it's a pleasure to meet you. I was just by chance, I just came on this link, and I thought that I did not know it was happening at this time, this presentation. I was fortunate that I got to come. So I'll put short and I'll come short directly to the question. Is that I've seen that in the Getcoin white paper, the, there's a lot of discussion about the mechanism, the economic mechanism. You talked about verification about of the users, and etc. etc. But I'm a little bit. I was not able to see, for example, from a privacy point of view, any concern. Of course, I see that the sharding concept is more of a reliability one rather than a privacy one. So, is there any inclination or any particular view? Like, for example, Zcash. Zcash is when they use cryptography in a way which kind of anonymizes the transactions using zk snarks. More precisely, it's a concept in cryptography.
German.
So, I mean, is Shardis somewhat interested in such initiatives from a cryptographic point of view as well?
So, with Shardis kind of just being a framework from which you can create your own networks, we don't impose any kind of privacy as a default, because like we may do that in Liberdis when we launch Liberdis using Shardis, but it's up to the application, right, to decide if what level of privacy they want for their network. So the Shardis software itself doesn't impose any kind of restrictions in terms of privacy and so forth. But I will say that one of the things that happens when you have a sharded network is that no one node in the network has a complete picture of the entire network, right? So especially when the state information is sharded, any node may only have idea of a limited number of accounts in the transactions that are happening in there and so forth. And so you already have this situation where that in itself provides a little bit of privacy. But if you really wanted to have a network that's a lot more private, you can also add like things like ZK Snark as a second layer privacy solution, right? Basically Zcash essentially took Bitcoin, which was not private, and then added the ZK Snark technology on top of that to make it private. So that could also be done with Shardis, but Shardis itself doesn't out of the box come with that. So
yeah, it's kind of layered architecture. It's like the SSL over
Right.
TCP or
Thank you very much. Thank you.
Sure.
Okay, maybe one last question and we'll be done. All right, so there are no more questions. Thank you very much, Omar, for the interesting presentation, and we'll have follow-up definitively on this, because there are lots of things that are kind of unique that needs more discussions.
Yeah, definitely. And I, want to thank you so much, Professor Hafid, for inviting me to do this presentation, and would love to, collaborate with your team to, see how we could work together and exchange ideas and so forth. So yeah. So, all right. Thank you very much, everybody, for joining. And I'd love to come back and present some of the other, topics that I kind of briefly covered on this time.
Okay, thank you. Bye-bye.
Thank you.
Alrighty.
Bye-bye.
Thank you.